Okay, so yeah, the critical value is, oh, excuse me, it's the z-score such that the area under the standard normal curve, and so real quick, for the standard normal curve, what's the mean and the standard deviation?
1 and 0.
So think back to chapter 6, right? What's the mean and standard deviation? Yeah, flip that, right? So the mean is 0 and the standard deviation is 1, right? And so when you're dealing with these critical values, it should always usually be between -3 and +3. And so here it's the z-score such that the area under the standard normal curve between -z sub c and +z sub c is equal to our confidence level. And then, yeah, so the notation for this, so the critical value is denoted with that z sub c, right? And so you find this the same way that we found critical values when we were doing hypothesis tests and when we were also doing confidence intervals for mu, right? So if I want to find -z sub c, what function in my calculator am I going to use? Also, you're going to need your calculators today. When you're finding critical values, what do you use? If you're told, so let's say I give you that c is equal to 0.9, okay, let's do 0.95 instead of 0.99. So if c is equal to 0.95, then what is this piece equal to right here?
Is it 0.5?
Okay, so if I have 95% of the curve is in between, how much of the curve is left over on the sides? Like, so 95, oh shoot, I think I just got hit by a bug. What did I get for sitting outside? I don't entirely know what just happened though. Let me make sure there aren't any bugs in my shirt. But think about my question. So if you have 95% of the curve in the middle, how much is going to be left over on the outsides as a whole, right? Don't think about on one side, but think about on both. Yeah. Anybody? Nobody wants to answer. Yeah, so you're gonna have 0.05 on both sides. So that means when you do that, you're gonna have 0.05 over 2 on this side, which is gonna be 0.025 on that side. And then also over here, 0.025. And so this 0.05 came from the fact that, like, how do I say this? So this plus this would be 0.05, right? And so then you have to divide it by 2 because you're just going to split it in half. Actually, let me do this. So yeah, and then to find this value right here, if I know that this is 0.025, then what function in my calculator can I use to figure out the z-score? Here, so I'll give you a list of options. Your options are z-test, z-interval, inverse norm, t-interval, t-test, yeah, inverse norm, right? So here you're gonna use inverse norm. So when you're finding critical values, unless, so here, let's make this a note. So unless you are not given sigma, so let's say, so the combinations would be you are given mu and sigma, or you're given p. So in those two cases, right? To find the critical value, you use inverse norm. So unless you are not given sigma, the critical value is found by using inverse norm or inv norm. So let's do this example. Oh, we already did it. I didn't think about that. I didn't realize that. So here it says, find the critical value for a confidence level of 0.95. Well, that's the picture I just drew right there, right? And so what you're gonna do is you're gonna have negative z sub c is gonna equal inverse norm. And then you're gonna give it the area to the left of that value. And so that's why I'm looking for negative z sub c. Because when I look for negative z sub c, I can just put in 0.025 and then comma 0, comma 1. And that'll give me the negative version of my critical value. And so remember, to get to inverse norm, it's not in the same place as the tests on your calculator. You have to hit second and then distribution. It should be the third one. And so you just put in 0.02501, and you're gonna get negative 1.96. So since everything is perfectly symmetric, what do I know positive z sub c is equal to? Yeah, positive 1.96, right? Because you're just going to take the negative of your negative value, or just like change it to positive, right? So it's 1.96. So that's the critical value, is technically the 1.96. So are there any questions on how to find critical values? And so I don't know if you guys remember, I'm going to go back real quick to the 7.2 notes. I'll go back to those to the 7.3 in a second. But there was this question where I had asked you to find the critical value when you did not know the population standard deviation. So rather than being given sigma, we were given S. And remember, we had to use that weird table that I showed you, and our critical value was given by T rather than by Z, right? So this is the table that I'm talking about. I don't know if you guys remember this. I had told you, just like, don't really worry about this. But yeah, so just keep in mind, when you're not given, if you're given the value of S, then you are not going to be able to use inverse norm. Okay, so there's a question. If a question just asks us for the critical value, you'd like us to give both positive and negative. Yeah, especially if you're doing it for confidence intervals, because when you're constructing a confidence interval, you always want to figure out like both pieces, right? Because your area, the confidence level that you're given, is always going to be in between the positive and the negative critical value. So when you're doing confidence intervals, it's always both of them. Where it's not always both of them is when you're doing hypothesis testing and you have a one-tailed test, right? So here, over here in green, so let's say I'm doing like a left-tailed test, then this is my only critical value. Does that make sense? And so it kind of depends on the question that you're answering. And so let's write that out real quick. So here you have confidence intervals and two-tailed tests would be both positive and negative critical values. Oops. And then, so this is like 1, and then 2, one-tailed tests is just one critical value. And you could take it even further. You could say right-tailed test is positive critical value, left-tailed test is negative. So right would be positive, left would be negative. All right, so are there any other questions about critical values before we move on to margin of error? Okay, so I'm gonna start scrolling. If you need me to go back up, let me know. But so here, I already gave you the definition for margin of error back in, like we've seen it several times, and so I didn't feel it was necessary to write it out again. But so here, oh, there's a giant bug over there. Remember, margin of error is the variable e, and that's the number that you're gonna add or subtract to your point estimate, right? And so you're gonna have e is equal to, so here, you're gonna get that number by taking your critical value, so the positive version of it, so the positive version of z sub c, and then you're gonna multiply that by p hat times q hat over n, and then the square root of all of that. So it's the square root of everything underneath of that, right? So here you can do that. And that n is also under the square root. So actually, yeah, let me leave those parentheses there. Be very careful about this because a lot of the times I'll see people writing things like this and then they'll forget that the n is also under the square root. So just make sure that you're putting it over everything, right? And so the process for finding confidence intervals for proportions so far is the same, right? You find the critical value, you use your critical value to find your margin of error, then you use your margin of error and your point estimate to find your confidence interval, right? And so let's go to the next example. Find the margin of error for the example on the previous page with a confidence level of 99%. Okay, let's go see which example it's talking about. Ah, this one, this example right here. So it says a random sample of 188 students. So we already know that. So here what I can do is I can say n is equal to 188. I know x is equal to 66. And I know, oops. Oh man, this might die. And then I know that, what else do we know? P hat is 0.35. And I know that the requirements are satisfied, right? So here I'm gonna take this and I'm gonna bring it down here. And then we are asked to find it with a level of 99%. So I can't use this critical value that we found up above. I'm gonna have to find the critical value for 99%, right? So here what I can do to find this critical value is, here's my curve. And then I'm told that in here I have 0.99 and I wanna find negative z sub c and positive z sub c. What is, so if this is 99% in here, then I'm gonna have 1% on either, on both sides, right? So the sum of this and the sum of this is gonna be 1%. So here I'm gonna have 1% divided by 2. And then here I'm also gonna have 1% divided by 2. So if it's easier for you to think about these things in terms of percentages, then go ahead and do that. But you're gonna have to convert it to decimals at some point, right? And so here when you do 0.01 divided by 2, you're gonna get 0.005. And so this is also 0.005. So then to find negative z sub c, I'm gonna use inverse norm. And then I'm gonna have 0.005, because that's the area to the left of negative z sub c. And it's the standard normal curve, so I use mean 0 and standard deviation 1. And so when you do this, you're gonna get, so let's do it real quick, 0.005, comma 0, comma 1, negative 2.58. So everybody should be getting that when they put this into their calculator. Which means that the positive version is 2.58. Okay, so now that we've seen another example of critical values, is everybody okay with this part of this example? Okay, so nobody's asking any questions. So let's take all of these pieces now and find our margin of error. And so what we're gonna have is, I know that E is equal to 2.58 times the square root. P hat, remember we found it earlier, it's 0.35. So this is 0.35. We also found Q hat earlier, but just in case you forgot, Q hat is equal to 1 minus P hat. And so you can just do 1 minus 0.35 right here. And then I also know that N is equal to 188. And so when I put this into my calculator, I'm gonna put all of this in parentheses, right? So be careful with that, because a lot of the times this 188 will not be underneath that parentheses. And so here, your margin of error is going to be 2.58 times, and then the square root button is above the x squared button, right? Can you guys hear that truck? You can, huh? Because it said I was talking and I wasn't. Okay, anyway. 2.58 times the square root of 0.35 times 1 minus 0.35, which is 0.65, and then divided by 188. Oh, I have a syntax error somewhere. Probably didn't close all my parentheses. Okay, so you should get 0.08, actually 0.09. Because if you keep rounding, so 0.0897, and so if you round that to 2 decimal places, that would be 0.09. So that's the margin of error. So that's the number that you're going to take and add or subtract to your point estimate. And so one thing I want to point out is you can tell if your margin of error is wrong, because think about what you're estimating here. When you do confidence intervals for proportions, you're estimating percentages. So let's say you get a confidence interval of like 0.25 to 0.75. What this means is you're however percent confident that something's between 25% and 75%. So if your margin of error is so large that it makes your confidence interval something that makes no sense when you convert it to percentages, like if I get like 1.26 to 1.47, then I'm saying that there's between 126% chance and between 126% to 147%, which makes absolutely no sense, right? And so here, you just have to make sure that your margin of error isn't causing your answers to go either below 0 or above 1, right? Your confidence interval should always be from at least 0 to 1, right? This is a terrible confidence interval because this means that there's between a 0% chance and a 100% chance, which that's everything, right? And so I'm just gonna erase all of this. And so yeah, somebody asked if the answer would be E equals 0.09. And yeah, you could give me either one of these if you wanted to. But if like, let's say for instance, the my open math stuff starts asking you to round to 2 decimal places, which I think is the most common one, then you're gonna put 0.009. And so I saw, like I did go through some exams. I haven't started grading them, but before it had closed, I went through some people's exams. And I saw that there were some issues where people didn't round, right? So some people put like 0.35 when they should have put 0.36 or something like that, you know? But yeah. So here, we can actually find this confidence interval, but yeah, so I don't have, yeah. I don't know why I didn't put an example of actually finding this confidence interval, but the way you would do that, so I guess we can do it real quick. is you're going to do p hat minus e and p hat plus e. And so I can move this a little bit over here. And so you're going to do, so that would be your confidence interval for this proportion, right? And so you can have that p hat minus e, that's equal to 0.35 minus 0.09. P hat plus e, that's equal to 0.35 plus 0.09. So the confidence interval that we would be getting here, oops. Whoa. So we did minus 9. 0.26 to 0.44. So that would be the confidence interval. So are there any questions about just margin of error or critical values or anything like that? Okay, so let's go on to this next example right here. Suppose that 800 students were selected at random from 2,000, right? So here, let me switch colors here. So 800, what variable do you think the 800 represents? So it says out of 2,000, 800 students were selected. Out of, or I mean 20,000. So yeah, here, if I were to look at these two numbers, I would think that this would be X and this would be N, but you have to keep reading this statement. So here, that's not actually the case. So it says 800 students were selected at random from a student body of 20,000, and they were given shots to prevent a certain type of flu. All 800 students were exposed, and 600 of them did not get the flu. So these are the two numbers that you actually care about. This is just the number in your population, which is actually given by capital N, right? And so here, this is going to be N, and this is going to be, not X bar, just X. And so P is going to represent the probability that the shot was successful. The shot was successful if a student did not get the flu, right? And so here, what you're going to have is you're going to have that P hat is equal to, oh wait, so the first part is what are the point estimates? So the point estimate for P would be P hat, and that's going to be X over N, which is 600 over 800, or 6 over 8, or this is 3/4, I want to say. And so P hat is equal to 0.75, or in other words, 75% of the sample did not get the flu, right? That's what this is saying. And then here, Q hat, that's equal to 1 minus P hat. And so 1 minus 0.75 is equal to 0.25. So are there any questions on this part of the example, just the point estimates for P and Q? All right, so let's go to, oh, this is really gonna die here. So we'll try and finish this example, and if this dies, then we'll just let it die. But so here, part B are the requirements for constructing a confidence interval for P met. And so remember here, so I'll leave this, what we have to do, the requirements are, the first requirement is it random? You know what, hang on real quick. Can you guys, did that lower the brightness for you? No, right? Because I just lowered the brightness on my screen. Okay. Anyway, the first requirement is if it's random and it says that they were selected at random. So that one's taken care of. The second requirement is that we have to check and see if it's normal. And remember, normal, you check that by checking that N times P hat is greater than 10. N times P hat is going to be that 800 times 0.75. which is going to give me 600. And then I need to also check that n times q hat is greater than 10. N times q hat is going to be 800 times 0.25, which is going to give me 200. So the requirements are satisfied. So yes. Okay, so for this next part of the example, finding the confidence interval, what we can do is we can do it by hand by finding the critical value and finding p hat plus e and p hat minus e, right? So that's one way of doing this. So this is by hand. But let's say you didn't want to do it by hand and you wanted to do it with your calculator. Wait, so yeah, so somebody asked me if I can explain why they were satisfied again, and so yeah, I can. So the two requirements, I'm going to scroll up real quick. The two requirements for constructing confidence intervals, this is what we had talked about on Monday. The first one is that it has to come from a random sample. And then the second one is that the distribution has to be normal. And if these two things are true, so if n times p hat is greater than 10, and if n times q hat is also greater than 10, then I know that the normality requirement is satisfied. Does that make sense? Okay. So if I scroll back down, yeah, so here's all the problems so far. But so yeah, this is how you would do it by hand. And remember, E is going to be equal to Z sub C times the square root of P hat Q hat over N. And so that's how you would do it all by hand, right? But if you wanted to do it using your calculator, the function that you're going to use is 1 prop Z int. So that's how you're going to do it using your TI 83 or 84, or even if you have an 89. And so when you do all of this, you're going to go to stat tests, and then you scroll down to 1 prop Z int. So stat, and then to test. When you select it, it's going to ask for 3 variables. It's going to ask for X, N, and your confidence level. And so if you're going to do it by hand, you have to make sure that you always have X, right? So make sure that you're not putting P hat in where you mean to put X. So here X is going to be 600, N is going to be 800, and our C level is going to be this 99% or 0.99. And so when you do this, so let's put this in 600, 800, 0.99, calculate. You're going to get 0.71057 to 0.78943. And then your interpretation. So let me scroll back up real quick. So yeah, you're going to say we are 99% confident that the flu shot will be successful for between 71% and 79% of the 20,000 students at that campus. And so the key thing when you're doing these interpretations is that it's for the population. So it's for everybody, not just the 800 students in the sample. You already know how many people didn't get the flu in that sample. You're not trying to estimate for the sample. You already know that. You're trying to estimate it for every single student at that school. And so you always want to make mention of either like the word all or everybody, or the fact that it's for the entire population. Does that make sense? Is everybody okay with that? And so here, let me put a little note. So estimating for the population. So are there any questions about this example? While you can use your calculator to find these confidence intervals, there might be some questions. Scroll down like this. What do you mean up? But there might be some questions where it asks you to find just the margin of error. And so make sure you know how to find that, right? Make sure you know the formulas. Oh, the confidence level, that's always given to you. So your confidence level is this thing right here. And so you always have to convert it to a decimal. So this is going to be 0.99 rather than 99%. Because when you put it into your calculator, it wants it as a decimal. Your calculator is never going to ask for percentages, by the way, or give you percentages. It's always going to give you the decimal form. Okay, so my iPad is on its last legs. So we're not going to do this next example today. We'll save it for Friday. I kind of want you guys to work on it though before then. Work on the quiz, definitely. Well, significance level is for hypothesis testing. So be very careful when you talk about that. So when we're doing confidence intervals, we're not going to start relating that to significance level until possibly Friday, maybe Monday, depending on when we get to it. But the margin of error, you don't always have to use it. So here, so let me kind of separate this. I didn't actually use it when I was doing this example, right? This is only if you want to do it. Here, what color should I make this? That's only if you want to do it by hand. You would do it that way, right? If you didn't want to do it that way, if you don't want to use the margin of error, if I didn't specifically ask you to use the margin of error, you can just do it this calculator way, which is just one prop z int, right? And so you don't always have to use the margin of error. Any other questions?